Okay, let us see now when we have a table and then there is a certain mass or a certain particle resting on that table, and then we have two bodies on that table with weights, this and this. So this is the question. Use the diagram below to find the acceleration of the particle, tension in the two strings if pulleys and the surface are smooth. So meaning you don't expect any friction force. So this is R force, this is R kilogram mass, and this is the 15 kilogram mass. Now because these two strings are different, therefore also the tensions are going to be very different. So now I start with this. This one, let me call this tension in this string T1. So T1, then this one also going to be T1. The one that is pulling this side and then pulling it that side. Also here, we are going to be adding T1 and then T1. Now the tension in this string is having T1 as its tension. When we come to this, let us call this one T2, the tension in these strings to be T2. Why? Because this string is not the same. So this one comes from here up to here, and this one comes from here up to here. So the strings are different. So this one is going to be T2. Also here I'm going to have the T2, the tension that is pulling that particle that's been up there. So now they were asking us to get the acceleration of the particle. Now, because this one is having a greater weight, it means that acceleration first of all here is going to be like that. Then remember now it's going to be pulling everything like this. So meaning on this particle, the acceleration is going to be in that direction like this. So meaning here, the acceleration is going to be up like that. As simple as that. Now, after doing it like that, after knowing the direction of the acceleration, when the direction of the acceleration, the rest are going to be very easy. Of course, now, this body, we said, remember the body is resting, it has what we call a reaction, and now this one is having a weight, which is going to be 10 G. This one is going to be having a weight acting on it as we get the mass times the gravity, the same mass times the gravity. Also this one, we get the mass, which is 15 times the gravity. Now this is going to be the weight that is acting on that body. Now the rest are very easy. Now to get the acceleration, of course we start with the 5 kilogram mass. 5 kilogram mass. What do we have there? We start with the direction of the acceleration. The acceleration is in that direction. That's where our acceleration is. Now what is it pulling in that direction? What pulls this body up there? We have now that all is our resultant force is equal to mass times acceleration in Newton's second law. So now what is pulling is T1 by being opposed by this force or this weight equal to the mass, which is 5 times acceleration. Remember, acceleration is going to be the same without, because these things are connected, so the acceleration is going to be the same. So I call this equation 1. Then I come to the 10 kilogram mass of particle. So it's that still the direction is going to be, now its acceleration is in this order. So meaning what is pulling it in this order? What's pulling is T2. Then what is opposing? It's being opposed by T1. Of course, our resultant force is equal to mass times the acceleration. Now, the resultant is going to be this one pulling, then minus this opposing, equaling to the mass, which is 10, then times the acceleration. So it's going to be the same because they are moving at the same. Now, the reaction, of course, the reaction is very easy. The reaction, because this body is moving horizontally, there's no any motion upwards or vertical. So that's why you said this one is just going to be equal to this. So, as long as moving horizontally, it means that the vertical forces are balancing. So, this is equal to this, as simple as that. When I come down to the 15 kilogram mass, now where is the acceleration? The acceleration is in this direction. In that direction, like this. So, meaning that now if I'm in this direction, what is pulling? So, the thing is on it is pulling, of course, our resultant force is going to be mass times the acceleration. Now, the resultant is going to be this force minus this, because this one is the one which is pulling in the direction of the acceleration. So 15g, then minus our T2 equaling to the mass, which is 15, times the acceleration. I call this my equation 3. So how can we easily solve these ones? These ones are very easy. You see, I have here T1 and T2. T1 and T2. Here I have T1 and here I have T2. So all I need to make here the subject. I substitute here or here. You make one the subject and substitute, and you have the same. Then you solve simultaneously. So now look at this. From 2, you see that? Now from 2, what should we make the subject? So let us make 2 to the subject. Our T2 minus T1 is equaling to 10A. We make 2 to the subject, so that now our answer is going to be 10A plus T1. And we call this one equation 4. Now what are you going to do with equation 4? Now you want to eliminate this one. So that we put this and we can easily solve with this. So that is the idea. We have 3 simultaneous equations and we have 3 unknowns. Life becomes easier. So now we say put 4 in what? Because I am making 2 to the subject. Now I'm putting it here. Don't use this equation because it's what we are using. So now you put it here. In 3. What is there? We have 15g minus T1 equaling, was it T1? Okay. T2 equaling 15a. Now we put our T2 there, 15g, now minus our T2, which is 10a, plus T1 equaling 15a. Simplifying, shall be having 15g minus 10a minus T1 equaling 15a. Take this beside, shall be having 15g minus T1 equaling 2. When you take this beside, it becomes a positive 25a. I call this equation 5. So we have T1 and G and A. Our G is known, so G is not a problem. T1 and A. So you can say, how are you going to start T1? So you just going to add. How am I going to add? I'm going to say equation 1, or we can start with this one. Equation, okay, we can start with equation 1 plus equation 5. Because I want to eliminate this T1. So equation 1 is T1 minus 5d equaling to 15a. Now I rearrange this. So I'm going to be having, I start with this, negative T1, then plus 15d equaling to 25a. Then we do what? We can ably add, because they are having different signs. So if we add this plus this, goes away, then this plus this, we shall get negative 15 plus this, we shall get negative, no, we shall get a 10g, because this one is bigger, equaling to 30a. So meaning from there, my a, you see this one, it's going to cancel, it's going to be a third g. What is my g? Know that our g is 9.8. Our g is a third times 9.8, which you can easily simplify to 9.8 over 3 meters per second square. Those are the units for acceleration. So now after getting acceleration, it means that from here I can easily come and I get now my T1. So from 1, we can abbreviate our T1. Okay. So from 1, okay, allow me to bisect this part here. From 1, what is it there? T1 is equaling to 5d plus 5a. If I take this beside. So we have this, we have this. So this one is going to be T1 equaling to 5 into 9.8, the gravity, then plus 5 into our acceleration, which is 9.8 over 3. So it's that we can use and simplify this to our T1. It's going to be this times this, that will be 15. So So 9.8 into this will be 15 into 20 over 3. So mind about the way I'm simplifying them, and simplify them in your own way. The one is going to be 9, 6 over 3. Now these are going to be in newtons, as simple as that. What you see when you cross multiply this 3 here, you get 15, and here you have the 5. So this 5 plus the 15, you get 20. This one is common, if applies it out. The LCM with the 3. As simple as that. Okay. You come here from 4. From 4. This is our 4. So our T2 will be equal into 10 into 8, which is 9.8 over 3. Then plus T1, which is 19. Okay, 196 over 3. So which you can every see that our T2 is going to be 98 plus 196 the whole over 3, which we can every get as this one is going to be 4. You carry 1, that will be 19. You carry 1, that will be 2 over 3, and these are in newtons, and so that will be our mass. Really easy. So you have our acceleration, we have our T1, we have our tension in the second string. Why do you think the tension in the second string is bigger than the tension in the first string? Why do you think that is the case? Because this one is having more weight, so this one is being stressed than this one, because this one is just having 5 kg. Anyway, that's it. I wish you well.